Good afternoon, everyone. I hope everybody's well, and we're going to try to refine your skills at writing hand-coded G&M code while we're away from class, and hopefully we'll cut this license plate frame when we return. This is kind of an off-the-cuff assignment. I did license plate frames before, but we're going to come back and do it again. And we're going to do this all with hand G&M coding, so you don't need anything. You can do it on your Chromebook. You can do it on your phone. You could also just write it out by hand on a piece of paper and then type it in the computer later. So here is our license plate frame. We're gonna leave the text to another day, so we're actually gonna do three different operations. So we're gonna write three different codes. The first code will be this, which is to just drill some holes so that we can bolt this down to a plate, and then we can cut around the outside. We can cut our text on it, and we can cut out the inside. So that is our first process. And then our second code, or Op2, would be to actually engrave the lettering, which I don't have prepared yet. I'm hoping that we'll be back at school and we can do that in class together. And then Op3 will be to cut out around the outside as well as cut around the inside. These two holes come in Op1. So that's kind of the overview of the whole assignment. So I'm asking you right now to write kind of Op1 and Op3. There is an extra credit opportunity on this one. So it'll be on the Op3 side. It has to do with the way you code. If you take and use tool diameter offset, then I'll give you more points. If you code just using the center line and doing the math to make it bigger, I'm going to show both methods in this video. I'm going to give you, I think I said it's in Schoology. I think it's like 120% you can earn if you do the harder method, which is the better method, but the other method will work as well. So a couple of things we need to do is we're going to start with these holes. So if we go over here, and this packet of this whole packet is a 3-page drawing. This gives you kind of the overview of the part, and then here is Op1. It gives you some instructions about what tool to use and calculating feeds and speeds and where the origin will be. The origin also is on the same spot in Op2. And then, so we're going to just start with the drilling, and then Op2 has, or Op3, I'm sorry, has this here. I don't know why. There we go. Has it here. I did kind of divide it up. So on the left-hand side has almost all the dimensions necessary, except for a few, mainly with the radiuses, to do the outside cutting. And then on the right-hand side is all the information needed for the inside cutting. Understand that because the origin is in the middle, that these change from negatives to positives depending on which side of the origins you are on. So that's kind of an overview of the assignment and what we want to do. So the next thing is, let's go ahead and let's hop over here to Op1. I'm sorry, yeah, Op1, which is to drill these 4 holes. And this is a really simple drilling cycle. So we're going to use a drilling cycle, a G81, to do it. So I'm going to go ahead and start by typing in Notepad. And I am going to try to minimize this kind of over to the side and bring up, oops, I'm sorry, wrong button. Bring up the drawing of Op1, and that's why it was kind of slid over. I'm going to try to zoom it, so there we go. And then if I bring up Notepad, we can kind of type over here. I don't have my dual monitor set up here. So the first thing we're always going to do is we're going to skip by. I like to skip by 10s. Remember, we should run with our capital letters on. N00, and then N 010 0 and 020. This should all be refresher from you. We're going to start out with the license plate frame OP1. Oops, we forgot some lines. We're actually going to cut this on the Haas, so we're going to do a little bit of different coding here. The first thing on all Haas's is you have to start with a percent sign and quit with a percent sign. So that's the first thing. And then the Haas's actually need a line number. I'm sorry, a program number. And that, for some reason, is the actual letter O followed by a 5-digit number. In your case, I recommend the last 5 digits of your student body number that you use. So everybody's got a different one. So we're going to put that in first. Then we're going to go ahead and start typing in our basic information that we use on all our codes, like what is it? This is operation 1. I'm going to add a line here and say mounting holes, so we know kind of what operation 1 is, and then who did it, and the date. Today is the 19th, I believe. Nope, I was wrong. It's the 20th. Lose track of days in this distance learning scenario. So, and then N40, and then what are we cutting this out of? We're going to cut it out of aluminum 6061. I'll have to order more hopefully when class gets back, because there's not enough for everyone to cut, but we'll figure that out when we get there. The stock size is going to be 12.5 by 6.5 by 0.1825, or 12.5 inches by 6.5 inches by 1/8 of an inch. Okay, and then N60 is going to be, what tool are we going to use? We are using tool 14, which is a 1/4 high speed steel drill bit. So there's our basic information. I highly recommend when you create the other code that you basically copy this and just make the modifications, like operation number 1 would be obviously op3. What we're doing is obviously different. What tools we're going to use is different. The stock and all the rest should stay the same. So why work harder? Work smarter. So like all our codes, we're going to start here on line N70. And we always start with the safety lines. That's G00, G40, G49, G80, and G90. I guess I'm used to Haas machines where you can just type it in and it'll automatically add the space. And then that's called our safety line. And 80, we want to set this into inches. And 90, we're going to set it as G54, our work offset, which comes from right there. And then N100 is G90, absolute program. We already set it here, but it's a good habit to get into. So our first line is N on 110. And in this case, we are going to call up the tool we want. So tool 14, M06, N120. We immediately have to go G43, which is our height offset. Tells us how long the tool is out of the spindle. And it has to have an H value that matches the T value. So our T and H values match, as you see right there. And then our next line is to start the spindle. So this is going to be an M03, and I'm going to use S10, which would be 10 RPMs, which is way too slow. I'm expecting you to use a calculator 4 times the cutting speed divided by the diameter, or more accurately 3.82 times the cutting speed divided by the diameter. Hint, hint, cutting speed's over there. And then that'll give you the spindle speed. And then we'll talk about how to calculate feed rate in a minute. N 140, and we now have it turning. We're going to head to the origin, so we want to head right here. So G00, X0, Y, not TY, Y0, and 150. We're now going to bring the cutter down to Z 1.0, so it's going to plunge down to right over an inch above the surface, and 160 to make sure our height offset is correct. We are now going to go G01, Z 0.1. So now we're about a half a pencil diameter above the surface of the part, and we have to give it a feed rate now. Now, once again, I'm going to use the feed rate of 1. You have to calculate it. that is the RPMs times the chip load times the number of flutes. Well, our drill bit has 2 flutes. Our chip load is written down here, so you should be able to calculate it based off your RPM. So now we're going to go N170, and we are going to now switch back to rapid, and we are going to wrap it off to our first location, which in my case I'm going to use here. And so that's X negative 3.5, Y 2.375. And so it's going to fly out to that location, and we're over the top, and then oh, I'm sorry, I made a mistake. We're not doing it in rapid, we're going to do oh no, we want to do this, G00, I'm sorry, G00. Because we want to go out there in rapid, because it would take forever to move out there at 1 inch a minute. So we're going to slow down. And now we're going to go N80, and we're going to give it the G81 as our drilling cycle. We're going to give it the same X and Y location, X negative 3.5, Y 2.375. And now we have to give it a Z depth of negative, and here's where it gets a little bit tricky. It's 1/8 of an inch thick. So but the drill point is pointy, so we have to go down deeper. And the math behind this is it is the diameter of the cutter times 0.3 normally gives you how much deeper you need to go. And then we add back the thickness of the material, and our depth should be 0.2. So Z negative 0.2. Okay, and then lastly, we have to do an R, which is a retract plane. So when it goes from this hole to this hole, how much above the surface do we want? We want to go 0.1 of an inch. And then simply N90, sorry, all we got to do now is give it the next location. So let's move over to this one. So this is going to be X negative 4.5, Y negative 1.75. And it will go there and drill a hole. And then you would give it N200, this location, and then N210, that location, and then N220, G00, which turns off the can cycle, so we're coming out of it, and it would go Z 2.0, which is going to raise us up above the surface of the part. And now we just need to end the code by going M05. Oops, I got to type in a line number. M05, which is a spindle stop command. N240, which is going to be G53. So we're actually switching from a work offset of G54, which is here, to the work offset that is the home of the machine, which is off normally in the upper right-hand corner. And we are going to basically tell it to send it to G53Z0, which is going to raise the table or raise the head all the way up out of the way. We're still in 53, so we're just going to go Y0, which is going to bring the table all the way closest to the operator, and then N260 is going to be M03, which is end/rewind. And I should put this home Y and home Z. So that is the code to write to drill these 4 holes. Obviously, you have to add a little bit and calculate some feeds and speeds for this to work. And then we should be good for this first code. So we could obviously take this over. We can obviously take this over now to by going select all, copy, and we can go over to our NC viewer and hit paste and hit plot, and it's going to give me some errors, but you should see that the holes are roughly where we intended them to be. The A G81 never comes through really cleanly in the viewer. That's okay. We can definitely check it. This is a simple code to check. So go ahead and use the NC viewer to help you in this situation. So I don't need this anymore because I already have it saved somewhere else. I'm going to be smart here because I'm going to skip over and we're going to do Op3, which is this one, or at least I'm going to show you how to get started in the video. So instead of working smarter not harder, I'd go File, Save As, and save it as Op3, and I would just go in and delete most of the guts of this code, which is probably just those 4 lines of code. I'll have to change those 5 at the end when we get down to the numbers, but as of right now, those are the 4 lines of code. I just need to come up here now, and we're going to change this to Op3. I'm going to call this 3A, and this is parentheses, license plate frame profile center. We'll call it center because we're going to use the center line of the cutter to do it. Seacrest aluminum, we're now going to use tool number 4, which is a 1/4 inch 2 flute end mill. We're using G54 at the same place. This is now tool number 4. This is now H number 4. I'm going to have to calculate the spindle speed on it because it is carbide, and I will add a note down here of what the carbide surface feed per minute is and the flute length, or in the chip load, I'm sorry. And then we're going to move back to the origin 1 inch above the part. So we're here right now. Now, if I bring up this picture really demonstrates what we're trying to do. We are trying to code the red dotted line, which is 1/8, half the diameter of the cutter bigger in basically all directions. Not always, though. So this is where it gets a little bit tricky. I'm going to do a little bit of the outside. I'll probably get to about here, and then I'll have you finish it, and then I will do a little bit of the inside, probably the same kind of thing, and then have you finish it as well so that we can understand how to do this. So let's go ahead and bring up our code. And I'm not sure if I can shrink this, maybe slide it over to the edge, bring up the code. There we go. That looks pretty good. So we have all the numbers. I wrote in some numbers on accident. I didn't realize I had it written right there, so I added it. Same with this one I didn't have. I had to add. So anyways, we're here in the center. We are going to start by going... We are actually going to, I'm going to start up here actually. We're going to go up over the top, come down, straight down, and go around the outside, and then finish over here around the radius. So N160. So our first move is going to be G01. Now we have to be careful here. We are going to go from here to there in a straight line. In rapid, we're going to have a bolt holding this down, this down, this down, and this down. So we have to be aware of, like, if we go out here, we could run over this bolt. So instead of going down here, we're going to move to our first location 1 inch above the part and then go down. So we are going to go to X, and that value is, so if this is 6.625 plus 1/8, which would make this 6.25, so 6.25, because I added 1/8 of an inch to it in X. And then in Y, it is 3.125, so 3.25 would be where the center line of this is, but I'm going to actually add a little bit more, 3.5 in Y. That'll hopefully mean we'll start off the part and then start plunging in. Now, now we're going to go N170. G0, we're going to actually go Z 0.0, so we're going to wrap it down, and then N180, G01, Z negative 0.3. Now the material is 0.125 thick. We're going to cut a little bit through into the backer plate, so it'll put a little groove in the backer plate, but after we cut it the first time, everybody will have the same groove. So we're now down up here. So our next line would be N190. And we are just going to go from here, up here, to down to this edge right here. Well, to get to this edge right here, I got to actually reference off this line there. So 2.625, but it's a negative. So we're going to go Y negative 2.625, which would put the cutter right here. And 200, we are now going to do a G02 for an arc. And this is probably the most tricky part. We're going to go from here to down here. So we're going to go 1/8 of a way further in Y, but we're actually not changing the X value any more than this. So our X is going to be 5.625. Our Y is going to be this plus 1/8 of an inch, or 3.25. And now our R value for the radius is also 1/8 of an inch bigger. So this was a 1/2 inch radius plus 0.125 puts us at 6.25. I'm not 6.25, 0.625. Okay. Now our next line, we're going to switch out of N to 10 G01 to make this long cut across here. We are now going from positive to negative, so it's going to be an X negative, and it's going to be negative 5.625. And then we can go N. Now let's take a quick stop. Let's go Control Copy. Let's go over to our simulator, delete, paste, and hit plot. So we can come, let's go home. So something went wrong. So let's go ahead and scroll down through this. Up, down, perfect, perfect. And here's my Y negative. Now I said to go X, this should have been Y negative, and hit plot. There we go. So you can see it made a nice curve, and now we just have to continue all the way around. But because I want you to actually do some work, I'm going to stop here and have you go all the way around. And I am going to jump ahead to right here. And when we come around this corner, we want to go straight just a little bit to make sure we get back in that other groove before we come up, and then move over to our new location. So I'm going to take off from where our up was. So this would actually be somewhere, depending on how you code, around 285. So N 280, I'm sorry, not 285. And we went G 00, Z 1.0. We have to go up this high because we have these bolts that we may run into, and we just want to make sure we're high enough that we're over the top of the bolts. Now we're going to move to N290, and we are going to move to X0, so we'll be on the center line right here. Y, the center, if we take this number and add 0.125 or this one and subtract 0.125, is exactly 2, negative 2.0. So we've moved directly to here. Now we can't, the cutter does not plunge straight down well. It's not a drill bit, it's an end mill. So what we're going to actually do is we are going to ramp in. So we're going to go down to, this was all done in rapid, Z 0.1, and then N310, we are going to go X negative 2.0, Y is going to stay the same, Z negative 0.124. So this is going to leave us a paper thin amount of material on the bottom, which should have enough to hold the license plate frame, especially with these two bolts, in place while we cut it. And then when we're done, we can basically just punch out the center and use the deburring tool to clean up the inside. But what it's going to do is it's going to move from here to somewhere about right here, but it's going to go at a down ramping angle. And when we finish, once we get all the way around back to the back side, we have to just make sure we come all the way over here and pick the cutter up over here to finish, to make sure we cut out all that ramping angle. And then we would go N 320, and we would then be able to proceed. Oh, this, by the way, needed to be a G01, my mistake. Then we need to proceed over. Let me slide this over a little bit. We got to proceed over to the end of this line here, which is shown right here at 5.375. So negative 5.375. Next line, N330, G02 again. X is now going to go to the center point of this, so we have to add an eighth of an inch or 0.125, which makes it to 5.5. Y is going to go to negative 1.875 with an R value of this radius is 0.125. We're cutting on the inside, so it has to be reduced by 0.125. So it's going to be 0.125. And then we're going to go N 340 and G01 and Z is going to go up to here, which in our drawing is 2.375. I'm sorry, not Z, Y 2.375. And then, of course, we got to turn the radius N 350, G02. X is going to negative 5.375. Y is going to the center line here, which is going to be 2.5, and the R is once again 0.125. And then when we come across here, this radius is half the diameter of the cutter. So we're just going to go to the point that's dimensioned there, then go to the point that's dimensioned here, and all of this is straight lines. And that little radius will be produced by the actual cutter. You don't have to program it in. And then we would continue all the way around, and when we get to here, you're going to just ramp out. So I'm going to show you what this looks like. Control copy. See if we made any mistakes. And hit plot. Oh, something's definitely not right. So let's see where we're going. Oh, I never made the repairs to this in the previous one, so that's looking good. So let's look down here. We went down. You'll notice that, see how it's ramping in? That's what we want. And then we go here, then we went over there, then we went way back over there because this should have been a negative. Plot. There we go. So you can see that we're moving all the way around. So this is the one where you're programming the center line. There's no extra credit for this. This is the easier one. It's a little more intellectual for you to understand. Okay, so I've gone ahead and now this is the second operation, or a second way you can do Op3, and this does offer some extra credit. You get about 120%. And what this is this is using cutter diameter compensation. So I've labeled this Op3B, and instead of center, I'm going to say cutter comp. So we're going to use cutter comp. And what cutter comp is essentially you're going to program the exact line that we want to cut out, and then we tell the computer to figure out the math based on the diameter of the cutter and make the profile bigger. So we don't have to do that. We just have to program the exact path we want. There's a few extra steps that will cause the cutter to adjust itself half the diameter bigger. It also means if we suddenly change the tool from, say, a 1/4 inch to a 1/2 inch, we wouldn't have to rewrite the code. We could just tell the tool it's 1/2 inch in diameter and it would improvise. So I'm going through and I'm changing this. So I changed those first two lines. We're still using tool 4. All of this changes, doesn't change. So tool 4, we're using tool height offset for 4 as number 4. We're starting the spindle. You have to calculate the RPMs. We're going to the center, and then we're staying 1 inch high because of the bolts, and we're going to move out up into this corner. So 6 1/4 and 5 and a little bit above. Now here is where our first unique line comes in, and that is we got to go N170. Oops. And we are going to use G41, which is cutter compensation to the left. So you have to think of it more like if I was the cutter, we want to go, we actually want to put it to the right, but we basically are cutting on the left of this line. So if we were on this line facing in this direction, we are on the left-hand side. So it's a little bit backwards, but you have to understand that. So then the X value is, we are up here, and we have to move it to a point on the line. And during this move, the cutter isn't going to do necessarily what we want it to do. So we kind of have to be in a position where we're not going to ruin the part. That's why we started way off over here. And now we're going to move to our point, and the cutter will compensate for that. So we're going to go ahead and go X to this point right here, which is 2.625. I'm sorry, that's Y. We'll leave that in because we need it. So this is X, and the overall width is 6.125. And in Y, so what's going to happen is the cutter's over here controlled on the center, and on this line, it is going to switch from being controlled on the center to being controlled basically by the side. We also have to tell it D04. And what that does is that's going to pull up the cutter diameter, which is in the offsets page, which is in the same location as the H4. H4 and D4 are staying in the same place. So I can put a 0 here. So T4, H4, D4 all have to match. And then the next line of code is, it's a much simpler method from this point of writing the code, because all we got to do is go, oh, this is going to be, I made a mistake. I forgot to go down right here. N165 G01 Z negative 0.3. And then an F rate I'm doing of 1 again. You have to calculate that. But now we're plunging. Now we're using a linear move. We're now linearly moving here under cutter diameter compensation. Now we're just going to go straight down the line. And the easier part about this is we're just going straight to negative Y negative 2.625, and then N190. X is going to go to 5.625, and Y is going to go to the full depth of negative 3.125 with a radius of 0.5, which comes right off the drawing there. And then N200, and we're simply going to go X to negative 5.625, and then N210, and go oops, I forgot up here, G02, G02. That means this needs to be a G01. And then we're simply going to go to the full X value of 6.25. Oops, that's negative. And the Y value is now negative 2.625 with an R of 0.5. And if we copy all this, and we then go over to our NC viewer and paste it and hit plot, it's showing the actual line we're going to cut. So you can see here, this is the angled transition where it goes from the center to the edge. The cutter's actually kind of moves straight ahead, but it's the cutter's going to move straight ahead, but it's actually transitioning its control point. So it's now going to show us the actual line. So that's looking very good. You can continue all the way around. The key is at the end, when we get back to this point, we need to move away in both X and Y. So all we have to do is move it to some other location, or we could just go right back to the start. I'll let you guys work on that. So now if we come back over here, I'm obviously going to skip over into the inside now. So the inside in this case starts around same location, about 280. So we're going to go N280. And we have gone G00, Z 1.0, pulled the material out of the part. In the previous line, N270, we should have had a G40, and most likely we would be going right back to where we started at X 6.25, Y 3.5. And that G40 cancels the cutter compensation, which we want to now turn off because we're no longer moving that. And then we're going to go to N 290, and we are going to go to X 0.0, Y negative 1.75. And then N300 is where we have to turn back on G41, and we're going to go to X 0.0, Y 2.2125, and D of 0.4. So we now turn the cutter compensation back on. We moved over here to some place about here, and then we just moved down to here, all in air. And now we are going to go N310, G00, Z 0.1, N320, G01, and now we're going to go X negative 2.0, Y, Z negative 0.124. The 124 is so we're going to leave a very thin layer of material on the bottom that'll hold it all together. And then when we're done, we can hit it with a hammer. It'll break off. We can use a deburrer to scrape all the edges and get rid of that little burr. So we've now cut from here under control. So it's on this edge of the line. And we've kind of ramped itself down. And then we can simply go N 330. We're going to go to X negative 5.375, and then N340, G02. X is now going to go to 5.625. That's a negative, my mistake. And the Y value should be going to negative 1.875 with the radius of 0.25. And then N350, we're going to go G01, X goes to up the side over here. So that point is in line with, I need to add that point. So we'll do that before I post the image from here. Okay, voila, I added that point we needed, 2.375. So it's not an X value, it's a Y value, Y 2.375. So it'll run up to there, and then we'll do another line, N 360, G02. Our X value is going to now reduce. Our X value is going to go to here. So negative 5.375. Y is going to go to the top of this, or 2.625. And then the R will be 0.25. So if we go ahead and we say select all and copy, and then flip over to here and select all, delete, paste, and hit plot, we can see that I've made a mistake. Pretty normal for everybody. So let's go ahead and just look down here. So it's going to be a negative number problem. I can already tell you right that. We moved here. That's perfect. and then this y needs to be negative. And I bet you if I hit plot, there's some of the solution. And then we went down, we ramped in, we went there, and then, oh, my value here is not correct. Oh, yeah. I had to push pause on that because I was like, why is it giving me that value there? And it took me quite a while to realize that this Y is supposed to be an R. And that's fixed. And now if we hit plot, there we go. And you see that it's moving around. And if we flip back over here, you're going to go to this point, which I've obviously dimensioned on this side, which is just the mirror of it. At least in the X and then in the Y's up here. And then you don't need to know this 2.5. That's only for if you're using the other method. And you need to continue. Okay, if we flip back over here, we've now gotten to right here. We're going to go out to this point here, which is above the this little fillet. Remember, we don't have to worry about this fillet because it's part of the cutter will make it for us. But we go ahead and continue around. Don't forget that we need to overcommit over here, then come up and then move back into position to turn off the cutter compensation before we end the code. So that should be enough information. At least we'll try it out. We'll see how many people send me emails and texts and Schoology comments on the things that I didn't cover well enough. So good luck. Hopefully this will take you about 2 hours. So between this, hopefully this will keep you guys busy for a little bit of time. And then hopefully when we get back in April, we maybe will make time to do this as one of our final projects. Stay healthy, my friends, and hope to see you guys soon.